All right, I do need to get these done, so I hope you can't hear my wife's stuff in the background. Unfortunately, I can. Let's see. I want to look at this wire here, right? And remember, there are two ways we can talk about a current. Right? We can talk about a current as the amount of charge flowing through an area like that in an amount of time. So in that case, the current is I for current is equal to charge over time. And a second way we can talk about it is as if we have a line charge density. If we have a charge density that's moving with a particular speed, right? So we have this sort of charged fluid in the wire here. It's moving with some speed, and we call that speed the drift speed Vd. And in that case, the current is equal to this line charge density lambda times the drift velocity. Okay, so that's what we're going to do. Is we're going to basically try to find this line charge density of free electrons. Those are the ones that are allowed to move here. Given that we know what Vd is, which is 10 millimeters per second, right there, and we have a current of 1 amp. So the drift speed is usually quite small, even though the electrons speed up really quickly, they scatter off of the atoms in the material quite readily. So we just want to look at something in that score. So we want to figure out this I equals lambda V, where we know what the where we know what lambda or I and V are. So I, we said was 1 amp, is equal to lambda times 10 millimeters per second. That's 10 to the minus 3 meters per second. Okay, so that means we want to divide through by this number here on both sides. And I'm going to flip it because I want lambda on one side. That's the one I'm solving for. So that's lambda equals 1 amp. So this is all equal to 1 amp as well. So you do it like that. 1 amp over 10 times 10 to the minus 3 is 10 to the minus 2 meters per second. Okay, and that is going to be 1 coulomb per second over 1 over 100 meters per second. So those seconds cancel out. So we end up with 100 coulombs per meter. And that's the line charge that's moving along here, right? And we could figure out this as well if we wanted to, but we need a little more information, I think. So let's see, what could we figure out? No, we'd need to know something about areas and stuff like that to do that. So that's number 1 for chapter 5. All right, number 2 will be Ohm's law. It's very simple Ohm's law.